Okay, the reason I have the tripod set up over here is, in these 2 meters, this is the clock on the left with the second hand on the bottom right, and then we're measuring, you'll notice that the resistance, we're measuring ohms, it says K ohms. You notice it's going up, 2.117. Sometimes it'll toggle back and then it keeps going up about 1/1000th every 30 seconds. And it has been doing this all day. There it is, going up to 2.118. And it's been at various speeds. It's not always constant, and I have no idea why. I'm theorizing that there's something going on. I don't know the HCAT or the Brown's gas world really well, but I'm guessing what happens is the plates are deteriorating or building up with, corrosion or junk on them, which affects the resistance across these 2 terminals, and that's why the resistance is going up gradually. And so today, when I took the water difference in, and I added distilled water in there to get up to find out how much water depleted, I used a syringe, a 50 cc syringe, this guy right here, to measure the, it's marked off to the milliliter, or to the 10th of a milliliter, and I filled that up with 213 milliliters of water, distilled water, to get from the last point to the first point. And that's going to be changed in the concentration of the KOH, potassium hydroxide, in here. And I am theorizing that that's going to change the rate at which this effect is going on, this resistance. See, it's now at 2.125 on that meter. And these meters were just not agreeing. I mean, if I put this one on, it says like, you're going to have to excuse me that I don't know the answer to this question. I'm guessing you can't take 2 ohm readings at the same time because they'll feedback on each other, because they'll be reading into the other meter. So I might have to disconnect. Just a second, I'm going to disconnect this terminal one so I'll show you that this meter is a lot different than this meter. Hold on. Pause it. Okay, here we have this one plugged in, and it says 1.0. And if I zero it out, take these off, and short it out, it says 0.9. So that's what that meter reads. Now let's show what this meter reads. Hold on a second, I'm going to get it hooked up. By the way, this is the meter we were using to measure the voltage on we weren't using my meter, we were using this meter to measure the voltage during the experiment across this. Okay, now I've got this meter set up, the TPI 275. It's set on ohms, and right now there's nothing hooked up. It says overload. And now I'm going to hook it up to this terminal. Watch that meter. That's like jumping all over the place. How are you supposed to read that? Now it's starting to stabilize. And this is where I first saw the effect this morning, where I was watching this, and I noticed that's increasing. What's up with that? Set the camera down and started recording it. It wasn't going up that fast. But that's crazy. That's on the kilohertz or kilo ohms. I mean, how are you supposed to take a resistance reading with your meter doing that? I mean, it doesn't stabilize. There's no steady state. There's no reading. And there's something else going on. I mean, you're going to have a second hand, and that's what I started today, is experimenting what's going on with this. So we started recording the data to try and document what's going on here. Look at that. That's just like crazy. The time, by the way, is 7:14. I'm going to hold this back so you can see both at the same time. Anyway, this is what this experiment was this morning. And today, why I had the camera there, was I was documenting the time and the resistance. So maybe that's enough for a pretty good data point on this meter right now. I mean, it's hard to believe and understand what's going on with your meter doing that kind of stuff. Maybe I just am onto a fact that's already well understood, and somebody just go, oh yeah, they've known that for 10 years, go read this comment or whatever. So looking forward to the feedback on that. Let me know my email, because I don't check my my Facebook messages hardly ever, like every twice a month or so. I just don't get in there. So that's not a good way to communicate with me. Just go to pesn.com, and the contact link is on the left-hand side, and you can see, contact me that way by email, preferred method, or Skype. SterlingDA is my username. But look at that. I mean, that's pretty crazy. So that's why it's hard to trust what's going on with these ohm meters. So I'm going to take this off and plug in this red one again, which is what we were using for the long-term test. We've taken a bunch of data points. I forgot to show you the shorting out of this, what happens. It goes to 0.03 ohms, 0.02, pretty close to 0. Okay. I should also mention, this is the meter we were using to take the current from the battery charger over to I had it on the, can't remember if it was positive or negative. I'm not sure if I wrote that down, but we'll have pictures that you can see that from, where we're taking the DC current. We had it over on the 110 amp setting. Okay, so now it's still equilibrating. I just plugged that back in. And it's almost like, oh, you know what may be going on here? When you send current across an electrolysis system, it activates the electrolysis. And so it's hard to get resistance, a solid resistance reading. That's what's going on. It's a function of the battery state of the electrolysis system, and I guess that changes resistance as it creates electrolysis. Go figure. That's maybe what's going on there. So I may have answered the question that you guys are going to go, duh, we've known that for 40 years. Well, I'm just learning it by first-hand observation here. So excuse my exuberance. But the question is, how do you take a good ohm reading, a resistance reading across your Brown's gas generator, so you can calculate using Ohm's law, using volts and amps, or volts and resistance in ohms, or current in ohms to get the other reading, the volts or amps. So I don't know how you're supposed to do that when that meter won't settle down. What are you supposed to call the true reading? That's my question, and those of you who know the answer, let me know. I'm very curious. Thanks. Oh, I forgot. I should just hold that steady for a second so you can see all the readings clearly without glare. Looks like it's starting to go into more of a, not equilibrium because it's still reacting, but it's slowed down. Now I'm going to zero this out so you can see what the okay, here's what the reading is when I zero it out. 0.0, 0.1, 0.2, 0.3, 0.1. So that's zeroed out. I'm going to hook it back up, see what happens again. Okay, let's hook back up. So all the way back down again to look how fast that's going up as you hook that up. So that's the question. How do you measure the ohms on a moving system? How do you say what the resistance is? Is there such a thing in a Brown's gas generator? So anyway, that's kind of wraps it up. Have a good day. Thanks for watching. Just going to let it run for a little bit. Get a little less glare on that thing. That first number's not going to change too much, 7.2 or 724. There you go. I'm going to start emptying the water over here. I'm emptying the water in this beaker until it gets close to the 1,000 milliliters. 2. I'm going to go empty that out. Put a hash mark for every 5 that I do. 5 liters times 1. I should videotape this. Too late now because you said you weren't showing it right at the beginning. At least you can see my methodology. 5. And a hash mark. Throw this out. Okay, I'm going to turn this off so I can document the emptying of the tub. With the second hand on the bottom right, and then we're measuring, you'll notice that the resistance, we're measuring ohms, it says K ohms. You notice it's going up, 2.117. Sometimes it'll toggle back to terminals, and that's why the resistance is going up gradually. And so today, when I took the water difference in, and I added distilled water in there to get up to find out how much water, it's not always constant, and I have no idea why. I'm theorizing that there's something going on. I don't know the HCAT or the Brown's gas world really well, but I'm guessing what happens is the plates are deteriorating or building up with, corrosion or junk on them, which affects the resistance across these, and then it keeps going up about 1/1000th every 30 seconds. And it has been doing this all day. There it is, going up to 2118. And it's been at various speeds. It's not. Okay, the reason I have the tripod set up over here is, and these 2 meters, this is the clock on the left,